these are the two standard curves. You can say one is E versus log P, E is void ratio and this is log P or effective pressure So, the curve is coming. So, now if I extend, this is my E0 and this point will be ER. This is CC1, CS, then 1, then this is 1 CR, you can plot it consolidation curve either void ratio versus effective stress or unit strain from where you can get CR prime and this is your CC prime 1. Now, yesterday means last class we have covered the CC, CC is your compression index. Two curves you can plot it, generate for your finding out CC, CR and CS. What is CC? CC is your compression index and CS is your swelling index, CR is your recompression index. Either you plot it void ratio E versus log P or unit strain versus log P. There is an advantage if you plot it unit strain versus log E curve, the advantage is like you can make this E versus log P, you can plot always convenient. It is a simpler, it is simple then to make less computational error. And another one is you can get directly settlement can be obtained directly from this odometer test or the consolidation test. You can go for void ratio E versus log P or unit strain. How do you get the unit strain? It depends upon this displacement of this dial gauge. From this displacement you can get your strain. If you plot the strain versus log P or effective stress, this is easy. There is a chance that with this plot there might be a possibility that computational error will occur, but in this plot this simple means less computational error may occur. Also settlement can be obtained directly from this plot. Now our next step is these are all your undisturbed sample from this field. There is an error between field and lab once you are doing laboratory test, odometer test, because of overburden pressure lost as well as your other constants. So there are certain corrections has to be applied with your E versus log P. Before I go for certain corrections for E versus log P, how to find it out pre-consolidation pressure. Based on the pre-consolidation pressure, you can say that soil is over consolidated or maybe normally consolidated. Now, determination of pre-consolidation pressure. Now, look at this curve. This is typical E versus log P. So, in E versus log P, you will get a curve like this. So, step 1 by your I estimate the sharpest point of curvature. That means by I estimate your sharpest point of curvature. From there, draw a tangent. Second step is through this point draw a tangent. Now, this point is it as a beginner it will take time. Once you practice, then you can easily identify where the sharpest point of this curvature. Once you identify the sharpest point of the curvature, then through this point you draw a tangent. This is a tangent, and with this a horizontal line is drawn. With this point a horizontal line is drawn, and this will generate an angle, say alpha. Now, third point is bisect angle alpha. Now, this angle you just bisect, it has been bisected, so it will be alpha by 2. Now, with this, from this curve E versus log P, identify bottom part of this curve where you can draw a tangent such that it becomes straight line, or maybe there is no more variation or no more change in curve. With this, or maybe curvature changes, with this you extend, so that with this tangent, this is second tangent. Now, you are getting point, this point is your PC. So, PC is nothing but is your pre-consolidation pressure. This point is your PC. That means, once again I am repeating, draw E versus log P. Then by your I, this curve, identify, estimate where is the sharpest point of the curvature. It may be like this, sometimes it may be like this, sometimes it may be like this. So, in this point, once you identify by eye contact the sharpest point, with that point draw a tangent. So, a tangent has been drawn with that point. Then with that point, through this point draw a tangent, through this point also draw a line. Then generate angle alpha. Once angle alpha has been generated, bisect this angle alpha, is means alpha by 2, and this bisect line has been dotted here by means of dotted lines. Bisect line has been plotted here by means of a dotted lines. Then at the bottom of this curve, identify, draw a tangent bottom of this curve from this where there is no more change in curvature. Then where it intersect, that point gives your PC, or pre-consolidation pressure. What does it mean with this PC or pre-consolidation pressure? It will indicate whether soil is over consolidated or maybe normally consolidated. Now, you can say that if PC obtained from this curve is greater than overburden pressure, or P0 prime, then what will happen? If PC is greater than in situ overburden pressure, then what does it mean? That means pressure at some time in past is or maybe larger than the present pressure. Then in that case soil is said to be pre-consolidated, or over consolidated. It is due to a greater amount of overburden which has been eroded, then change in water table Now, whatever we are getting here PC, pre-consolidation pressure, if pre-consolidation pressure is greater than your overburden pressure. What is this overburden pressure? Suppose we collect soil sample below the ground surface at a depth say h. With this h, what is your overburden pressure? Overburden pressure is your gamma prime h. So, in that case whatever we are getting pre-consolidation pressure from consolidation curve, if it is greater than overburden pressure, that means what does it mean? Why it is greater than? That means in past, recent past, pressure at some time, look at here, in recent past pressure at some time is larger than the present pressure. Whatever pressure present here means till today, earlier the pressure on this ground was larger. It was due to, because this overburden which has been earlier, it may possible in the past there are some surcharge, it was existed, maybe due to rain or maybe due to man-made, maybe due to certain things it has been eroded away. That means it has been removed or it has gone. Then second part is your due to, suppose water table is always there maybe in the ground surface, due to this rise in temperature the water table goes down. So, change in water table also it causes pre-consolidation pressure greater than your overburden pressure. In that case we say either it is a pre-consolidated or over consolidated soil. Pre-consolidated means it has been consolidated earlier, or over consolidated means it has been consolidated earlier. That means the pressure earlier was much more than the present pressure, that is your gamma prime into H. Now, there is another term, it is called OCR, that is called over consolidation ratio. OCR is over consolidation ratio. It is nothing but PC, pre-consolidation pressure, by P0, that is your overburden pressure, If it is greater than 1, then it is called over consolidated. Then if it is 1, that means it is called normally consolidated. If it is less than 1, this is called under consolidated. Now, over consolidation definition I have explained right now. Now, normally consolidated, that means in recent past whatever pressure above the soil mass was there, right now the pressure is same. In that case it is called, that means Pc is equal to P0. In that case pre-consolidation pressure is equal to overburden pressure. So, Pc is equal to P0. So, in that case it is normally consolidated, that means the consolidation process has been started, it is normally consolidated. In over consolidation or pre-consolidation means the consolidation process already started in the past, it was already consolidated, so it is just continuing. Now, if Pc is less than P0, what does it mean? That means it is under consolidated. That means pressure in past was less than whatever pressure, overburden pressure now. That means the consolidation process has not been started yet. So, these three terms will be used throughout this course: over consolidated, normally consolidated and under consolidated. So, this clarifies at what condition it is over consolidated and what condition it is normally consolidated and what condition it is under consolidated. Now, whatever we are getting undisturbed soil sample in the field, the moment we bring this undisturbed soil sample from field to lab, so this overburden has lost. As I said earlier, once you collect the soil from undisturbed soil from the field, the moment I collect the soil, take out from the field to the lab, that means this major prime of this overburden pressure has left, means it has completely gone, as well as this pressure, confining pressure also, it has, sometimes it lost, sometimes it is there. So, to simulate, means the moment you bring it back to lab, then you go for consolidation test. Whatever the curve you are getting in the laboratory consolidation curve, that is not truly representing your consolidation curve of field. So, to do it, certain corrections required. So, that is why I write it here, steps in correcting undisturbed curve. Now, there are three conditions, three parts. If I divide it, one is normally consolidated clay, other is your sensitive soil, another one is your over consolidated clay. In case of normally consolidated clay, if you look at here E versus log P curve. Now, in this E versus log P curve, this is the curve you are getting in the laboratory. This is laboratory undisturbed curve, but that does not mean that it will represent true curve of this field. That means certain corrections required. Now, P0 means lab value based on your Cassegrain, then P0 prime is your in situ overburden pressure. Now, with this step 1, first find it out initial void ratio E0. I have written all the steps. Compute E0 using G, natural moisture content, and overburden pressure. Using G, natural moisture content, Wn is your natural, N means natural, W is your moisture content, natural moisture content and overburden pressure. Once you get E0, that means this is my E0. from E0, that is your point A is your E0, draw a line AB through E0, this is E0, draw a line AB, then you identify, this is a log P curve, you identify where is the pressure equal to your P0. P0 is your lab value based on Cassagrande. So, this point is your P0, so this point is your B prime. Now, this AB you extend it, AB line you just extend it. Now, from this third part is from the bottom of the curve draw a tangent where this curvature is not varying much or it is straight line. From this point draw a tangent and extend this line, and this tangent has been extended. So, it intercept A B prime at point B. So, your B and C, this is your corrected Virgin curve for field, corrected Virgin curve for field, and whatever you are getting CC, this is your true CC representing your field condition, but whatever you are getting here earlier, that is your CC related to your laboratory test. So, be careful, once you get it done in the laboratory curve, the corrections for normally consolidated clay is required. So, the steps are like this. First identify, once again I am repeating, first identify E0, means first calculate E0. E0 is initial void ratio using G, Wn and P0 prime. Wn is your natural moisture content, whatever you get it in the field conditions. Then from point E0 draw a line AB, from point E0 draw a line AB, and you identify where is your P0 in log P, so that B point you can get it. You are getting E0 as A point and B point automatically where P0 is there, pressure in the lab, you can get it here. So, AB, join the AB and extend, and from point C draw a tangent, that is the bottom part, draw a tangent and extend it. From point C the tangent extended where it intercept A B prime at point B, this is your B and C is your corrected Virgin curve, and from this slope you can find it out CC, coefficient of curvature representing your field conditions. Now, second, there are three cases as I say, one is normally consolidated clay, other is your sensitive soil, another is your over consolidated. In case of sensitive soil, so first identify what is your B prime is located as extension of, if you look at the point 1, step 1 means you draw, this is your E versus log P, E versus log P, draw the curve. So, it has been drawn. Then point B prime, if you look at here, the B prime has been located. First same step, first you identify, first calculate E0, with this E0 find it out. Suppose this is my E0, this is your point A, then the curve, generally sensitive soil, the curve will go in this way, all of a sudden it will point of inflection, then it will again asymptotic towards log P. So, point B prime is located as extension of line Ij. I have taken 2 points in the point of inflection, that is, one is I, this is I, other is your J, I and J. Point B prime is located as extension of line Ij from point of inflection I of the undisturbed curve. This is your undisturbed curve from laboratory undisturbed curve. You can say laboratory undisturbed curve. Now, you identify where is your point of inflection, first point is, first step is calculate E0, mark point A, from E0 mark point A. Then second step is identify the point of inflection, say I and J. With this I J, draw a tangent or draw a line, extend line of extension from I J, where it intercept with this line E0 line. This is called E0 line parallel to log P. With this E0 line where it intercept, then extend line AB to D. Once it intercept with this, you are getting line AB. So, extend it AB to D. How you are extending the to D? From this point C, draw a line perpendicular. Draw perpendicular from point C, it goes here, where it intercept AB, and here this is your point D. Now, you draw the field curve. This is your, particularly this is your laboratory curve. Draw the field curve. M2 is equal to, that means M1 BD by B prime and D prime. This is my M2. M2 is coming from, M1 is here to here, M2 is here to here. That means this dotted line is my corrected virgin curve, and this is your M1, means this is your laboratory curve. So, M2 you can find it out, M1 into BD, BD by B prime D prime. So, for different sets of values of M2, you can get sets of M1. Once you get M1 value, this corrected curve can be drawn. Once you get corrected curve, then you can find it out the slope. From this slope, you can get CC or coefficient of curvature. This is your corrected CC. This is your corrected CC. Now, these are all two. Another one is for last part is your, that is your C, this is your B part is over. Now, C part is your, there are three, particularly we have drawn three cases. One is normally consolidated, other is sensitive soil, third is your pre-consolidated soil. Now, in this case of pre-consolidated soil, just draw your E versus log P. This is my E0, this is EC, this is the PC, and it is P0, and this is A, and this is B. Steps. Compute P0 and E, E0, P0 by means of Cassegrain method, E0 from natural moisture content, G, and from overburden pressure. draw a line locate P0 PC obtain slope of rebound by I as line x x and slope CR. Through A and parallel to x x, draw line AB. Now, for pre-consolidated soil, draw the laboratory curve, undisturbed curve from your consolidation. Then steps are as usual, compute P0 and E0. E0 you can get it from natural moisture content from G and P0 prime, I say here. Then draw a line E0A. This is your line, E0 line, draw with this. Then locate P0. Then locate P0 from here, where is the P0 is there. This is your E0A line, you can get it. Then find it out PC by means of Cassegrain method. Then obtain slope of rebound by I. If you look at here, slope of rebound means this is going this curve and all of a sudden coming down. Now, if I unload it, it will then load it, it will rebound. So, this point will be your slope of rebound by I. By I you identify where is your slope of rebound as a line x x. Draw a line x x with that point and through A. Once you draw the line x x, point A is already there, E0A with corresponding to P0, with A parallel to x x, draw another line. So, it may go somewhere else. Now, at point C, draw a tangent and extend it, where it will intercept line from A to parallel to x x at point B, That means CB represented corrected Virgin curve of field condition. This is your Virgin curve for laboratory condition, this is your corrected Virgin curve in case of field condition. You see, here you can find it out also CC with your laboratory undisturbed curve, but a correction is required. Similarly, because overburden has lost here, similarly in case of pre-consolidated soil, you can get it correction curve from BC. So, these are the particularly three cases we considered the correction to be required. One is normally consolidated clay, second one is your sensitive soils, third one is your pre-consolidated soil. This is your C. Once you know the corrections, you can apply and find it out what is your corrected Virgin curve. Once you get corrected Virgin curve, this CC has to be used for other calculations like foundation design and in soil mechanics point of view, not this CC. Laboratory undisturbed curve, from here you will get whatever CC, it has not to be used rather than this curve will be corrected, and whatever CC you will get it, you will find it out, this CC is your corrected CC and it can be used for settlement calculations. That is it for today's lecture. Thank you.